Hello, everyone, and thanks for joining us today for our webinar, How Power Modules Solve Power Design Challenges, sponsored by Mauser Electronics. I'm Kelly Kurd, Marketing Manager at MPS. I'll be joined today by Rochelle Quintana from Mauser Electronics, and George Stathakis will be our primary presenter. He's one of our product marketing engineers. So today we're going to learn about new challenges for power solutions, how modules address these challenges, and then we'll go through some application examples. At the start of the presentation, Mauser is going to share with us some of their new logistics and website enhancements that simplify the buying of our products. A couple of things to be aware of as we get started here. A recording of the full presentation will be available for streaming, as well as a downloaded PDF of the presentation itself at monolithicpower.com/webinar within the next couple of days. Everyone that's registered will also get an email directing them of where this will be. Everyone is muted during the presentation, but at the end, you'll have the opportunity to ask questions. With the interface that you're in for the webinar, if you mouse over the bottom, you'll see a control panel that has a QA button. So when we get to the end, we'll open up time for the questions, and you can just type them in there and we'll make sure that they get addressed. And with that, I'll turn it over to Rochelle from Mauser to get us started. Thank you.
Good morning, everyone, and thank you, MPS, for inviting us to host this webinar with you. You all know MPS for their great products, and we know them for a great partnership, too. Mauser is the world's leading MPI distributor. We take pride in being focused on new technology. We have no minimums on most products that we offer, same-day order processing, and next-day deliveries on most orders. Next. This is an idea of what it looks like to be a world-class global distribution center. Average order processing time is about 15 minutes, and we process about 65,000 lines per day. We have 43 vertical lift machines, which is the most in North America. Next. We are expanding our warehouse. This is a look into our new robotic order pulling. We're really gearing towards automation. This is our auto store, which is going to make us faster and more accurate. Next. So another look into our automation, the Perfect Pick machine. It's some just really neat automated machines that are going to help us process all of your orders. Next. We've added some things to our website. This is the Mauser parametric search. It's an easy-to-use, product-aware smart filters, which are going to help you find parts that meet your specifications. Next. Our BOM tool, we're constantly updating and trying to make better for you guys. The new design offers a design risk for each line of your BOM to make sure that you're getting the most out of the parts you're choosing for your future projects. Next. We've added some conversion calculators. One is the resistor color code calculator, and the other is the Ohm's law calculator, just to try to make things a little bit easier for you guys and have you quick access. This is a look at our resistor color code calculator. You have the ability to enter the amount of bands you're using and each color, and then you can display matching products that fit your resistance and tolerance values. We also have some applications and technologies listed on our website for you for new product training and application guidance. This will help you find technical resources and some articles on current technology and industry trends. Mauser is the leading distributor for MPI. We're focused on design, engineering, and R&D all the way to production. We're continuing to evolve with the goal of being a one-stop shop for engineers and buyers alike. Thank you, Kelly, for allowing us to be a part of this, and I'm looking forward to watching.
All right, thank you, Rachel. So hello, everyone, and good morning. This is George, and I'll be going through the power module portion of this and the main discussion. So to give you a bit of an overview of what we're going to talk about, so we're going to jump into a lot of the challenges that we see today in the industry for power solutions in general. And then we're going to jump into what is an MPS power module and how do we address these current issues in the market. Mainly going through how MPS power modules make much easier to use and shorter development cycle. They reduce size, thermal, EMI, and make full system integration much simpler and easier. So to kind of start this off with an overview of the current power solution market and what we're really seeing as industry trends here at MPS, and how we're looking to drive those trends and really lead the industry forward, is we're seeing a lot of customers who the faster time that they can develop their product means that the quicker they can see revenue growth. And of course, this is, a common sense kind of factor here. And so our power modules, as you'll see going forward, really allow you to address this issue of a shorter time to market. We're also seeing today that designs are becoming much more compact, and this is demanding a much more higher power density. We are also seeing that there's a lot of strict EMI regulations that need to be met. And we're seeing this a lot of demand from our end customers where they're trying to meet their strict EMI regulation. And this can be a challenge for traditional discrete design. And so we're going to talk about how power modules now make it simple and easy for you to address that without having to burden you or your team with those resources. Then we're also going to address how power modules are addressing complex and multi-rail systems. And we'll dig into a little bit more about how these problems are impacting the market first, and then we'll jump into how power modules are solving all of these issues. So the key thing that I'm going to drive first is about the issues that we're seeing, and then we'll jump into how modules are solving those. So one of the first things is the shorter time to market. And of course, this leads to a higher share of the market ownership and gives you a bigger lead to generate more revenue. And we see this as a key factor in driving a lot of our customers to use power modules, is now that you have a lower R&D cost, which is less burden on you and your team. And then you can now focus more of your effort on your core design and your core product, and then be able to bring your product to market faster, giving you with a higher market share. Also, traditional discrete power solutions that are available today on the market can take upwards of 18 weeks to develop. They also require a lot of engineering efforts on a lot of teams, and this can tie up very need to use resources, which makes it difficult for teams to focus on their core values and what they are really trying to develop. So this is something that here at MPS, now we're trying to solve with our power modules and really shorten the development time frame. Another thing that we're seeing, another trend, is that as power demand for devices goes up, board space is becoming more and more precious. And so being able to reduce the amount of board space that a power design takes up is critical in a lot of power designs. And so as we'll dig into in a little bit, the power modules are really a space-saving key. As you can see here from just a few board examples, the power solution takes up most of the board. And that is a very common problem we see with a lot of our end customers, is that the power solution is now occupying more space than their core product or what the main function of the board is. Going along that, the higher power density poses some thermal design challenges. This can be because the higher system density now can limit airflow. We have a higher ambient temperature, and so this really is pushing the power solution market to be able to handle these kinds of requirements. And as we'll see, power modules are a perfect address to this problem. And then another thing that we've really seen our end customers run into is EMI regulations, and they're getting more and more strict. And being able to debug, the EMI and then test it, it can require a lot of resources from you and your team. And this can also require multiple revisions of your PCB design. And so here at MPS, we're trying to limit that and basically take that EMI regulation and being able to mitigate that into our power modules so that it's a ready and done solution to go down on your board. And then kind of jumping in, a little bit more to that issue is that, the EMI market, and as we've seen more and more requests for this type of mitigation, the debugging of it's very difficult. And so this can put a lot of burden on a lot of our customers' engineering teams. And so being able to bring that in-house now and let MPS solve that for you is something that our power modules are ready and fully equipped to do. And this will require you then to spend less time of your resources and your team resources, requires less PCB revisions or none at all, because now we provide you with a power solution that's ready to go. Then the last thing is that our complex system designs now that we're seeing in the market is that a lot of FPGA SoCs are really demanding a lot of rails, and they're demanding a lot of high performance rails. And so this can make it challenging when you're trying to deal with your sequencing requirements. And as we'll jump into now, we have power modules that can directly address this issue, making it much easier for you to take care of a very complex system design. So first, to kind of start off, is what is a power module? So MPS's power modules, we now integrate the inductor and most of the passives inside of a single package. So this allows us to be a much smaller form factor than a traditional design. And this allows us to now cater and bring in all of the complex design into a single package so that our end customers now can just place this down the board, usually just provide with an input and output capacitor, and the solution is ready to go. So one of the big advantages to our power modules is that it shortens the development cycle, because now MPS is doing all of the work for our end customers and we are doing the full power solution design. This can shorten the development cycle by over 70%. Most of our power modules are basically, like I said, a drop-in solution where an input and output capacitor is all that's needed. We already optimized the performance based on the power modules input and output specs. And so then this will make it so that the design is already catered. We also have programmable power modules now, as I'll talk to in a little bit, which now allow you to even cater the design even more. These power modules also really simplify the layout with our advanced packaging technology, and the way we do our pinouts makes it very easy for you to drop it down on the board. And then all of our power modules require very minimal external components, usually just the input output capacitor. And then in some cases, depending on how customers want to cater to their feedback, they can adjust that as well. So as I briefly mentioned, so our power modules, we really focus on trying to simplify the PCB layout. And this goes back to our pinouts of our devices. We always try and make it so that the input and output capacitance is easy to put down on the board, and that the overall layout of the device is very easy. And this, really makes it nice and simple for you to do your board layout now with a fully integrated solution. No external compensation or anything like that needed, and everything's embedded into a single device. And the example here that I'm showing is actually our 100 amp power module, which can be quite a daunting task to design if you're working with a discrete solution to try and do a 100 amp power solution. But as you can see here, the layout is very simple with our VN and V out pins very neatly placed, convenient areas towards the edge. So it makes it very easy for you to lay out your ground plane, V in, V out, and then we have our signal pins right over to the edge. So it makes it very easy for you to do your PCB layout. So now I kind of want to jump in, and we're going to start talking about more of how power modules address the issues the industry issues that we had discussed earlier. And so we'll start with kind of the smaller size. And this can be attributed to our monolithic power stage, our flip chip packaging, our increase in switching frequency, and our 3D packaging technology that really increases our power density. So now we'll jump into kind of detailing how we do all that and how that really helps address your guys' size constraints. So a traditional design for a discrete buck converter, as you can see, they use a external high side and low side FET. And so because of this, since it's not all one integrated power stage, the solution already takes up a much larger area. Where because of our monolithic power stage, we now integrate the high and low side FET into one die, and this greatly reduces our module size. So even compared with like the other industry modules, which are shown on the left, our modules now are even smaller just because of our die technology and the fact that we can integrate everything onto a single chip. Also, conventional design uses a wire bond, which this increases the area of the chip drastically. Whereas we use a lead frame and we actually grow copper pillars to the die, so we can directly connect the die via flip chip technology. And this allows us to really reduce the solution size of our module even further so that we don't have to use those wire bond connections. We also use much higher switching frequency, and this allows us to shrink the inductor size. As you can see with like a traditional discrete design, the solution area is much larger than our module design because we're able to reduce the inductor size drastically by increasing the switching frequency. In this example here, you can see that a conventional discrete design would be switching around 300 kilohertz, and our modules can switch up to 2 megahertz, which this can cut the solution size in half. Our 3D packaging technology also allows us to increase power density. As you can see from a traditional design where the inductor has to be placed off to the side of the IC, we can now actually stack the IC on the board and then place the inductor on top and then encapsulate it into our module, which makes for a much smaller solution size and much smaller footprint on your board. So as you can see from this X-ray image, we actually stack the inductor on top of the IC, and this allows us to reduce the board footprint, which gives you guys more space to work with your other and core, items you want to place on your board and really reduce the power solution. Now kind of jumping into how MPS power modules tackle the thermal management problem. So all of our modules are optimized to reduce power loss. This is one of the core things that we drive at MPS and all of our modules is high efficiency. Our flip chip packaging reduces our thermal impedance. We have really low profile modules available, so if you want to use it under a heatsink. And then our 3D packaging helps evenly distribute the heat so we can have a nice uniform power dissipation. So the first way that we tackle the thermal management problem with our power modules is that they have very high efficiency, and this is really because of our optimized inductor design. So we source the highest quality inductors, and then we optimize the whole design around trying to meet the modules and the design's peak efficiency. We also use a very thick copper lead frame, and this reduces the resistance so that we can dissipate any excess heat to the board. Like I said, though, the driving the high efficiency home with our power modules, and if you've ever checked out our modules, you'll know that our efficiency is definitely the industry leading, and this really drives home any concerns about people having with trying to put enough copper down their board to dissipate any excess heat. Our modules are already designed so that the heat or the power loss is very minimal, and so that the footprint area of the module can handle that dissipation. And this is optimized for a very nice layout design. And so we work with knowing the size and footprint of the module and the pads that are available, and then knowing the power loss so that we can optimize the full solution. And then our 90 nanometer BCD process reduces our FOM by almost 30%, which is a very significant contribution to making our modules much more efficient and much lower power loss. Our flip chip packaging is also key in reducing our thermal impedance so that the module doesn't store any heat. So a conventional design, because it's not a flip chip, can hold a lot of thermal and a lot of heat inside of the module molding, where ours, because the die is now attached directly to the lead frame, we can dissipate any excess heat directly to the board very uniformly. We also offer really low profile modules, which makes it easy to pack it under a heat sink, or if it's being used for like a FPGA or SoC design, these really low profile modules can fit under the heat sink. And we've seen this solution actually quite often with our end customers, where if they need to keep the power solution close to their main chip for noise reasons, they can now also pack it under the same heat sink. We also, our 3D packaging technology helps uniformly dissipate the heat. And this can also help with, airflow. And if you have forced air cooling in your device, this can also help uniformly cool the module. So now to kind of dive in a little to how power modules are helping out with the EMI regulation and EMI reduction. So we integrate and use a dual-sided input capacitor, and this cancels noise in the hot loop. We reduce the switching area to mitigate EMI, and then we can use a spread frequency spectrum to adjust the rate at which the voltage is changing. So our integrated dual-side input capacitors that we use on our modules, a traditional buck can generate a very strong noise due to the pulsating current in your high and low side FET and the input capacitor. And because on most designs, there's only one IM capacitor on one side of the module, this can generate a lot or most of the EMI noise that comes from a power solution. And so what we'll do with our modules is make them so that on the layout, it requires two input capacitors on both sides of the module, which now the field generated by the hot loop is canceled out because of the opposite directions of the noise flow and the current flow, which makes it so that now because of our optimized layout, it'll reduce the EMI noise emission from our modules. And as one of our examples, our NPM 3596, this module is a high input voltage module and was specifically designed to be able to have this noise canceling, hot loop where we have dual input capacitors, and this greatly reduces your EMI emission. We also will reduce the switching area of our exposed switching area for our modules. And so this is another way that we reduce the EMI emission. And so now because the module and the switching node is completely kept inside of the module in most cases, it's now not exposed to your PCB board. So that noise from the switching power supply is isolated inside the module, and it's not passed from the module to your board to the plane and then passed or emitted into other devices. And so this makes its power module's probably biggest advantage is the encapsulation of the switching node and keeps it isolated from your board. Another way that we can attack EMI is by doing a spread frequency spectrum. So we can adjust the change in voltage so that we can move any spikes in the switching spectrum so that it's outside of where the EMI regulation needs to be, so that we can reduce the spurs on your switching frequency. This allows us to keep it so that we meet the EMI tolerances. And so we're able to spread out the switching frequency so that we can reduce those spurs and meet the EMI tolerance for your design. So then I want to talk about a little bit how MPS modules solve, really complex system designs and higher current systems. We now integrate multi-output modules that have built-in sequencing. We have scalable modules that can scale up to 800 amps of output current. And our modules use COT control, which can help them adapt to really high transients while also reducing the output capacitance. So a big thing that we've seen and a big industry trend has been really complex system designs that require multi-rails. We've seen a lot of this now with the FPGA SoC market. And so now we offer power modules that are fully integrated with inductors that have programmable sequencing. As you can see here, the example that I'm using is our MPM 54304. And so this device has built-in sequencing. And so it allows you to now, either through I2C or we can pre-program the device, you can actually change your sequencing to meet the device that you're trying to power all internally. So there's no external sequencer needed. And we can fit this entire solution in an 11 by 11 area, including the input and output capacitors. So this makes for a much smaller solution design, and it allows you to now tackle the sequencing problems of your device very easily and quickly. As you can see here, we actually, with a single device, we can provide a full power solution for an FPGA chip, making it much easier for you to carry out your designs. We also now have scalable power solutions, and this is really helping our customers address designs where maybe they need to change their current depending on the board rev or the design they're doing, or they need something where they can, really demand a lot of current for their core device. And so, as I said earlier, we have devices now that can go up to 800 amps of output current, and then they can all be scaled and multi-phase together with PM bus control. So it gives you a lot of flexibility to be able to provide and cater to your end solution. And then our modules also, we use COT control. And so this allows us to provide a much faster transient response. And this is really attributed that we can adjust the switching frequency on the fly to adapt to the load conditions. And so this allows us to not only meet your transient requirements, but we can also reduce the output capacitance that's needed, which significantly reduces your total solution size. And this has been really a key advantage for MPS driving in the higher end performance markets, where we've seen customers demanding very high slew rates up to 200 amps per microsecond or more. And we're able to easily address that with our constant on-time control by adjusting the switching frequency. And we can also now, make it so that their solution's much smaller with reduced output capacitance. So as I mentioned before, we offer programmable power modules, which I said for like sequencing, and then also for being able to cater to your individual design. That's one of the big advantages now at MPS, is that we offer modules that before the typical industry standard was that a module was very fixed in how it was designed because of everything was integrated now. But we've been able to now create digital modules where you can actually, with a full integrated solution where the inductor and compensation feedback are all integrated, and now you can just go online and program it to your own customized needs. And so these programmable power modules, which you can actually go online to our website now and just play around with the input and output. And this allows you to really cater your design, and we allow you to change all types of specifications of the modules so that you can meet your transient or slew rates, so you can meet your output, requirements, ripple requirements, and then you can actually simulate the design and make sure that it meets your requirements. So now I'd like to open it up to the QA portion. I thank you all for listening to that. I know it was a little bit faster this time for this webinar, and we're going to plan on having more webinars in the future where we'll dive into a little bit more detail on more specific topics. But I'd like to open it now up to the QA. So if you have any questions about our power modules or how we can address your specific issues, please let us know. So I got a question here on the pricing and how it's positioned compared to competitive solution? So that's a great question. And our power modules really attributed to our monolithic IC that's embedded inside the module. If you take a look at a lot of our competitors, they source their all of their components, especially their FETs and IC or controller, from other providers. So they don't build them in-house, where we use all of our own FETs, or our full integrated power stage is all our own. So we can really control the cost on that side. And also, because of our monolithic design, this greatly reduces our production costs. So right there, we can already offer a significant cost savings over traditional module. And where we've seen ourselves placed, and why our module group is growing so fast here at MPS, is now we've even been able to compete with the traditional discrete designs because of all the advantages and that we pack in to a single chip. Especially when you start talking about sequencing, programmability, all of those different features that need to go into a single device. Now that we pack that into one chip, it really makes it so it's very, very price competitive with even a traditional discrete solution. Okay, so I think that answers that question. I do have a question on, do you have any FCC approved modules?
So for this, we have some modules that can meet the FCC standard, and we are also doing the EMI test to make sure that we have the module, because some customers are going to use that for automotive qualified, and we are designing the module to make sure that it can meet the standard. Yeah.
Yeah, so I think if that answers your question. Any other questions that or anyone else that has any other questions?
George, it looks like we had one come in via the chat panel, and the question was, I want to design the following specs: variable input, 15 volt 2 amp to 9 volt 2 amp, constant output, 5 volt 3A. Can I use MPS solutions for this? So
sure. So I think all our modules can implement. They are all designed for variable input voltage range, and you can have a fixed output voltage. And we have different modules with different output current ratings, from very low current to like 0.7 amps to 100 amps. So it's a very huge, it's a large current rating range that you can select from. And also for the output voltage, it will be fixed. And we also offer two ways to set the output voltage. And one way is to use conventional voltage divider to fix the output voltage. And the other way is we can also use PM bus and I2C to control the output voltage without using the voltage divider, which will be very convenient.
Yeah, so I think, and as Zichen was saying, we have plenty of modules to fit that type of requirements. And so, as he was saying, we can provide, even I2C adjustability for the voltage, or fixed feedback resistor adjustability for your output voltage. So we do offer plenty of solutions. And I have another question here on, how do you provide support if I have questions? Well, MPS has many different avenues of support. We do actually offer our best way of support is our MPS Now program, which we now have available, where you can actually reach out and schedule a time to work with one of our engineers or an FAE live. And we do have email, which is mpsnow@monolithicpower.com, which you can actually send the email directly to. You can also call us. And after this webinar, Kelly will follow up and can follow up with a link to that as well, so that if you do have questions or you need support, This is a new program that we've started here at MPS. And like I said, it's fantastic. And we've seen great traction with our customers with it, because now you can actually set up a time if you're working with a product or one of our power modules, and you need to like debug your board or try and work out an issue, and you want to talk with one of our engineers, you can actually set up a live call where you can see us working with your board in real time. And this is a terrific way for you to get support on our products. I have another question here on an application that says it'll require 12, I assume 12 volts, low power, 2 watts, DC to DC, 5 volt to 24 volt converter. What issue will I run into with respect to EMI compatibility, and does MPS have a solution for this?
Yeah, so for this question, I think we have, well, MPS offers the boost modules for this application. And for the EMI, because the output voltage will be like high, so I think it will pose some challenges for the EMI. But as George just mentioned, we do have the solutions to deal with this, such as we can adjust the DVDT of the switching, so that if you have lower DVDT, it will lower your noise emission, and we have the dithering function that can also help mitigate the problem, in which we don't switch at a single switching frequency point, and we will switch at some in a range instead of a single point. It will also help mitigate the EMI emission. So that's our solution for this.
And then another question is talking about, can we get better efficiency with modules? So this is a great question. In comparison to, I guess I'll start with, in comparison to other modules on the market, MPS is definitely driving the highest efficiency by far. I'd say with our new programmable modules now, or I guess, let me step back, for traditional discrete and controller designs versus a module, I'd say there usually is some sort of sacrifice to efficiency when going to a module, and that's really, you know, driving the smaller solution size. What we've been able to do now, though, before you jump to any conclusions on that, is that because of our programmable modules now, we can really fine tune the design so that it can really meet the requirements per your specification. And so you can actually play around and adjust the switching frequency a little bit, or adjust a bunch of the other parameters to try and cater to an efficiency target that you need. And like I said, all of our inductors we source are the highest quality inductors, so we try and reduce any losses there. And then our monolithic design is already very high efficiency. So I'd say overall we're targeting, and we've seen a lot of our end customers now who are looking for high efficiency designs for even acceleration cards or data center designs, where we're able to drive high enough efficiency, 90+% efficiency on our power modules to meet that kind of that requirement. So another question on the PCB design software you are providing part model. And so I assume they're asking for what software we offer our part models on.
Yeah, so for this, I think we can provide the Altium design files, and if needed, we can also provide the Allegro design files.
Then we have a question. The question regarding the up converters, but I need 12 of them on one board. Oh, I see. It's just in regard to the question above about, oh, okay, so he says he has 12 low power. So he has 5 volts going up to 12. So he says he has 12 of them on one board, and how will that affect the EMI? And I think it's similar to how you answered it before, correct?
Yes, yes.
So I think even to that question, even with 12 of them on the board, that's really going to be more of I would assume, a space challenge problem. So the EMI we can still easily address, and like I said, we can even set up a better discussion if needed. But being able to adjust the switching frequency as well, so we can spread it out if there's no requirement on a fixed frequency, that can easily address the EMI issues of that challenge. Then another question for the programmable power sequencing, do I need to have a microcontroller for the design? So no, for our programmable modules that have multi outputs, you do not need to have MCU. We can actually pre-program the device for you. And if you can use our online tool, which we offer 3 devices now, and then we offer some others that aren't available on that tool that you can work with us directly, and we can actually pre-program the sequencing on that device. So then when it comes to you, it's all ready to go, and you just drop it down on the board, and it'll operate as intended. And then if you want to change it, or you want to change your design, you can just send us a new request, and we'll program a new module for you and send it to you, and you can put it down on the board and try it out again. The only need for like MCUs if you want to be able to control your I2C bus and be able to change something on the fly. But like I said, MPS can work with you to just change the programming and send you a new module to evaluate again. So it's a very easy process. I thought I saw a question on the chat.
Yeah, it looks like we had one, George. Can these modules be used for automotive application or high temperature and vibration?
Yes, so we are designing the automotive qualified modules, and for the high temperature, because our module have lower power loss, so at the same like high ambient temperature, our module can be used for higher temperature.
Yeah, and all of our modules are industrial grade as well. So they're already meant for a higher atmosphere or temperature performance. And so this makes it easier to kind of cater to those designs. But as Zichin said, yeah, we're already designing in automotive applications, especially to meet the strict EMI requirements, and also because of the low power loss and heat and thermal emission. And then we have another question. What is the minimum order quantity for a pre-programmed part? Well, so for our online tool, there's no minimums. So you can actually just order one. That's why I said it makes it so easy to go online with our tool and optimize and customize a module. And then you can just order one. We also offer evaluation boards with that too. So you can actually order an eval board with your program module. And so this will make it super easy for you to get the design, and then you can, run it through your lab and test it. And then if you like, you can come back to us with the same program configuration, and then you can order more, or we can even go into like, more production run if needed. So there's no minimum order quantity, and the lead time on those from our online tool is very short. Usually our delivery times within 5 to 10 days of you placing the order. If we need to go and do a module that's not yet available on our online tool, if you contact us directly through like MPS Now, we can still work with you on programming and getting you parts if you need for your board design. So really on most of our programmable modules, especially the ones that we offer online, there's no minimum order quantity. And then another question on, if you have a 5-volt 3-amp output, do I need to add a heat sink on top of the device?
For this question, so for the 5-volt and 3-amp, I think it's the power is not high, so and also because our module efficiency is high, so the power loss will be small, and the heatsink is not needed in this case.
Yeah, I wouldn't see any reason to need a heatsink for that kind of power consumption. Okay, I think that's all of the questions.
I don't see any more as well. I will add, it looked like there were several questions about automotive or EMI. We have done several webinars on that topic. If you go to monolithicpower.com/webinars, you can see the presentations and you can see the on-demand videos. So you might want to go take a look there, and we'll be continuing next year, more of that series of webinars, so be sure to keep an eye out for those. And then for this one, again, we'll have this available online as well. Should be by the end of the week, and we'll send out an email, and I'll also put in there the information about the MPS Now program that came up. But if there's nothing more, I'd like to thank everyone for joining us today and look forward to continuing the conversation with future webinars. Thank you.